next one. So hi, I'm Jamie McCusker. I'm going to be talking about my knowledge graph framework, Whyis, today, and specifically how I've been using it to create knowledge graphs, both from documents and from data. But just as a programming note, I realize that so many of you probably have never actually seen Whyis or what the point of it is, even, especially with there are a lot of commercial knowledge graph frameworks out there. So I decided to kind of refocus the talk on the basics of kind of Whyis, how it's put together, the motivations behind it, and why I think it's special and interesting to work with. So first off, let's start with Whence Whyis. So where did Whyis come from? Hence Whence. So I actually started Whyis not with the name of Whyis, but it started with a question of what does it mean to have a nanoscale knowledge graph? And so first I like, well, wait, nanoscale, because actually at the time I was working with nanomaterials, but I realized that also, so there's a thing called a nanopublication, which is essentially it's three named graphs. There's an assertion, which is the one we normally think about. It is a very simple named graph in a knowledge graph where you would put the knowledge that you normally think of. But how do we know that this is true? Well, we want to be able to provide provenance about those things. That's the provenance graph. That's graph number 2. Number 3 is the artifact as a whole, the nanopublication itself. How do we talk about the provenance of the nanopublication? Who published it? When was it published? And kind of, that sort of stuff. And that's the third graph. So it's basically, 3 named graphs, very simple. People sometimes think of nanopublications as always being very small in terms of number of triples. You can have 1 billion triples in your nanopublication assertion. It doesn't matter as long as they all have the same provenance. From there, I started thinking a lot about the kind of the underlying promise of the semantic web, especially the semantic web layer cake as it exists today and has existed in the past. And the thing is that there was a promise there that there's all of these cool things we can do with semantic web, and a lot of them have been realized in kind of special use cases here and there. There are things around provenance and trust, and things around reasoning, and things around being able to do data integration across large number of data sources and even large data sources. A lot of things around triplification, as it used to be called, or what I call knowledge curation. And really, there are all of these, I call them bluffs. Okay, so I said, well, let's call all the bluffs at once. What happens if we put together something that can realize what everyone's been trying to do individually into an integrated platform? And the last piece is that I was involved with Prov back in the day. So kind of between nanopublications as a function of, or structure for kind of capturing graph provenance, and Prov itself as a way of describing that provenance, we actually have a lot of really interesting opportunities for knowledge graph management. And the last piece is, of course, linked open data, which of course is, there are a lot of linked open data platforms out there, but they are basically publishing containers, right? They don't necessarily do a lot with these other things. And so, and the last, of course, is domain ontologies. This one is my favorite, SIO, Semantic Science Integrated Ontology. But the thing is, when we actually pull all this stuff together, these are Legos that are supposed to click together. And so let's click them together and see what we can do. So the other piece, of course, is that when you use Whyis, everything is standards based. We are working with RDF front to back. There's no relational database in it. Everything is tracked through the use of Pravo and nano publications for revisioning, truth maintenance as possible, using the provenance that we provide through Pravo, because we can say that one nano publication is derived from another. And we, of course, it's a linked data native. That was like a afternoon project to implement a linked data server on top of, a triple store. And we can actually perform entity resolution using kind of like all the, as I call it, labelish properties that are out there, which there's a number. We can publish data sets using DCAT. And we can create views based on the ontologies that we load into the knowledge graph. So when we say, hey, this is a DCAT data set, let's make a view for data sets and have that be a way to render the view for it. I'm not pushing the button hard enough. But what is Whyis? So as I said, it's a nanoscale knowledge graph publishing management analysis framework. So the idea was originally that this is basically a workbench for performing knowledge graph research, and then immediately turning around and operationalizing the outputs of that research into a production-ready knowledge graph framework. So someone can come along and create a new entity resolver. They can evaluate it against large-scale knowledge graphs, test it, and then publish a plugin for it that can then be integrated into production Whyis knowledge graphs immediately. Same thing with any knowledge extraction approaches, any knowledge creation approaches, any new visualizations that might be available. The idea is that it's all pluggable. It's all something that doesn't have to languish as a research project on an underused GitHub repo for 5 years before someone notices it and tries to incorporate it into their framework. When you actually use this, it's already there. It's ready to go. And essentially, the idea is that we are building knowledge graphs using the best of breed capabilities from both the commercial space and the research space to be able to say, hey, these capabilities can be put together without having to worry about any underlying framework issues or compatibilities. So how do we do this? Well, we start with a software stack, of course, because everyone loves their architecture diagrams. So kind of from bottom up, we use Gina Fuseki. Now that is obviously it's open source. It's available for use to everyone. It has some query complexity issues, and it eats disk like a pig. But it's open source and everyone can grab it. It's also standards compliant enough where it is a reference implementation that can be plugged, that someone else can take a commercial database, plug it in without really any trouble. We also use, so one of the interesting things about Whyis is that it natively supports data-based artifacts and resources in the graph. You can upload files. You can upload a lot of files into Whyis and have them be stored in a file repository. Each file that you upload gets its own URI, and then you can publish metadata about those files in place in the graph and be able to do things like transform it into RDF if you like. You can serve it up. You can do whatever you need to do with it. And so we publish images, we publish data, we publish documents. It all can go into Whyis or not because it's just a URI. And so you can just reference it out on the web instead if that's helpful. And then finally, we use Celery as the basis for a distributed inference agent system that I will talk about in a minute. But on top of all that, we have essentially a user interface system and a knowledge inference system. We can then provide custom views, basically we can do on-demand loading of linked data using importers. And on top of that are basically a bunch of user interfaces based on things like Vega Lite, SiteEscape.js, Vue.js. We use material design. We're trying to kind of keep it nice and cool and sexy. But the thing is that all this stuff up here is all replaceable. You can customize everything front to back on the user interface, on the knowledge curation side. You can replace the database. It's all pluggable. This is kind of the ecosystem that Whyis enables. You have the ability to essentially build out a set of knowledge curation capabilities, both in essentially knowledge extraction. If you like MRebel, you can write an agent for that. If you have a prompt-based knowledge extraction tool that you like, you can write one for that. And you can couple that with semantic ETL approaches, both standard ones like RML, but also kind of more domain-specific ones like semantic data dictionaries, and my favorite semantic ETL tool, Settler. That, along with the ability to map in linked data on demand, that all gets fed into ontologies. But the thing is that the interaction with users also produces knowledge. And so all of this, of course, is the basis for, everything kind of comes in as its own nano publication. And then the knowledge inference system also keys off of that. It says, hey, here's a new chunk of knowledge. Let's use what we see here. And, am I, as an agent, interested in this? That am I interested in this is just a SPARQL query that gets run over this chunk of knowledge that we've basically atomized at the nano scale. And we then have, the other side of an agent is a Python function that you can then produce some new RDF, and that gets added to the graph, gets added back to the cycle. Inference agents, as I said, this is really, you fill in this blank here and this blank here, but this is all there is to an inference agent. It's really that simple. You get some RDF lib resource objects for kind of the resource in question. You get some input information in one graph. You write output information to another graph, and you send it on its way. And that's all there is. And then what happens is that the life cycle of these nano publications basically means that you have transactions essentially coming in from many different places. They all get pushed to the SPARQL endpoint, and then there's kind of, as that's being managed, that gets run against every registered agent that's in the system, and they can do all sorts of stuff, including things that we haven't imagined yet because it's very open-ended. And you can, as you write your new knowledge graph, you can add those agents as you like. There are ways of testing them. But once it's actually registered in this, it kind of works in this process. You run that thing, that creates a new nano publication for every time that function runs. And that adds new nano publications to the graph and starts the process over. And so for those of you who are familiar with reasoners, this starts looking like a forward chaining reasoner, and that's because it is. Except that your head is a Python function that produces arbitrary RDF. Your body is a SPARQL query that can match against arbitrary RDF, which makes it a very, very powerful and very easy to make very complex, basically inference steps within your knowledge graph. You can tie in, obviously, large language models. You can tie in, we can and do tie in, whole whole-scale knowledge curation and pretty much everything else. Now onto the user interface. So as I mentioned, we have a type-based user interface. We have the ability to take, basically this is a matrix of the, hopefully that wasn't a spoiler. So basically for every type that you have, that you're interested in, there are actually a number of different views. So view is that standard thing. You just go to a web page and you see it, right? That's kind of a normal way of looking at things. But there's also other things you might want to do with the with entities in the graph, including editing them, creating new ones, finding things that are related. Edit again. I don't know why. Anyway, looking for instances of, for instance, class. And so you'll see that between the view itself and the type, that basically creates a matrix of templates that get rendered. These are all Jinja templates, people who know how to write, who know how to code web applications that'll look very normal and kind of run-of-the-mill for them. But one of the cool things about it is that there are data views and there are web views. And the data views will drive user interfaces. And so you can actually customize what you see in a user interface based on these data views without having to change the interface itself. Conversely, you can consume, so for instance, with related, you can actually consume that against a number of different things. So if you're looking for things that are similar to it, that's interesting to a web page, but that's also interesting to a network explorer. And so so we basically treat these as cross-functional contracts, and I'll show you a better example of that in a second. We also have kind of leveraged the fact that we can, basically store SPARQL queries as entities unto themselves, and pairing them with a tool called Vega Lite, which is a way of writing very simple schemas for visualizations. And you're actually able to get build out either very simple or very complex data visualizations. And actually on one of our projects, we had a material scientist, not a computer scientist, not a programmer, but a material scientist he got very enthusiastic about it and create over 100 different visualizations for the materials mine knowledge graph, including some fun ones like a Happy New Year. The other thing we do is that there's this ability to, because again, we're talking about kind of cross-linking views with user interfaces, we can define some of these fairly closely and be able to say, hey, this is how if you're looking at links out from an entity, we can basically say, hey, this is how you do it. This is the structure that we want, but we don't have to stick with simple subject predicate object. So obviously, I know a lot of you don't like reification, but I always think of reification, what one person's reification is another person's object that everyone else likes to ignore. And so I like using reifications because it realizes things that you probably didn't think were actually important. And so here we basically let you kind of build out a kind of these interactions, which can be, again, complex or simple, depending on the graph. Oh, did I just skip over? Yeah, I did. Okay. The other thing is that because we have this view here, essentially this gets composed, these templates get filled by SPARQL queries. And so we can do some really interesting stuff with this, including, you can have multiple SPARQL, multiple matches to a given link in there. And so what we can do is we can actually combine them, in this case with Stouffer's Z method, because in some of our knowledge graphs, we actually have probabilities attached through the nano publication to the assertions that are in the graph. And so we can roll those up into a cumulative probability for multiple assertions for it. So if you have a classifier that has a certain level of confidence, you can pair that, you can join that into an ensemble of classifiers and basically provide consensus predictions on your actual whatever it is you're saying. And this is actually this is a network explorer. This looks really complicated, right? So this is actually one of the values of using that sort of roll up. This is every interaction that Jean Valjean, yeah, every person that Jean Valjean interacts with in Les Mis. It's a lot of people. But the thing is that some people are fleeting and they come and go, and that's fine. And in this network graph, you get one link for every character interaction. If you roll it up to kind of the people he interacts with the most, you can actually see a narrative structure in here. You can see who he interacts with the most and who they interact with the most. And essentially, we do that simply by filtering on that on the meta-analysis that we performed. We're also able to customize those views. So here we actually have like a this is a reified participant that actually does basically we have two people interacting here. Here it's just a simple subject predicate object, and so depending on the query you use, that lets you kind of roll that up. And so it's almost a way of projecting an RDF graph in customizable ways into a linked property graph, except that you don't have to worry about those pesky flat properties that you get in LPGs. Similarly, if you have classes of things, sorry. If you have classes of things, is this for me? Or is this someone else? My smile. Yeah, I wasn't going to drink first. These are classes, right? So classes work differently from instances, but we're still using the same views. What I do is that essentially I have the ability to roll up these views and say, hey, this is how we might want to look at how these things interact with each other. So sorry. Going back to charts, this is kind of showing narrative flow of, thank you, of the graph. Oh my God, thank you. Your lifesaver. Oops. We're also able to use, the Vega team also has this tool called, I don't remember the name of it. I did, didn't I? Did I? Oh yeah. So, okay. So you're able to view, so you're able to edit these things, but then you can also, so that this is a more complex Vega visualization from before. The y-axis is the number of interactions, or the number of appearances of a character. Oh man. The colors are individual characters. So you can see, so this bit here, this is actually Jean Valjean. You can see that in this book, he just disappears. This might be the one where he talks about the French, he does like a lot of weird digressions. and yeah, that's probably one of those. We also have the ability, obviously you want to publish it, so you have the ability to kind of create the visualization as a resource in and of itself, which means that you can add metadata itself and it becomes a member of the graph, same as everything else. Data Voyager is the name of a tool that they have that actually lets you kind of build these sorts of visualizations, use kind of drag and drop, and we've integrated that as well. This is an example of a nano publication. This one's very simple, but it described the data that we loaded to actually produce the Les Mis graph. It comes from, there's actually they're available on GitHub. And then what we do, and so this guy, Mad Studio New, actually provides it. He did some kind of cleanup and curation to finish out Donald Knuth's work. But basically, we have the ability to say that, hey, yeah, Jamie made this a while back now, and we can also say that this the data that the file conforms to a particular data dictionary, and so then we can actually process it and actually run it through. So when we load this file in, we actually just get this RDF. It records this, but then the semantic data dictionary agent looks at this and says, hey, there's an STD in here. Let's make a template for processing it, and then that hands it off to the semantic ETL agent, which actually processes it. And finally, what you came here for is real work with like knowledge extraction. This is kind of hot and not quite off the presses. Basically, we have the ability to, so this is a there's a dialogue agent here that I'm actually talking with, and don't worry about the null values here. That's actually, those are actually tool calls. Those are responses where you don't have necessarily any output, but it's actually producing triples that are pulling in. So what it's done is, in another conversation, I told it about myself. So it actually went and looked in the graph and said Jamie McCusker is an ontologist because that's all they had. And so I said that I went to RPI and advised with Deborah McGinnis. So basically I went through this thing and kind of described myself. And if you actually go into the graph for me and look me up, it's actually pulled that out, and it actually does that in a fairly consistent way. And next steps are to using context learning to be able to customize how this is created, and so we can actually build graphs in the style that you need, rather than the style that people have been training knowledge extractors for the past 10 years, which is basically Wikidata, which is great, but not all knowledge graphs are Wikidata. Behind the scenes, we're also, this is kind of where it came out of. Behind the scenes, basically, we have this idea of kind of pulling in, use schema.org. Actually, it doesn't show what I thought it would show, but this is actually from another project where we were doing scene graph extraction through dialogue. And so we use the activity stream framework to actually represent dialogue in the knowledge graph. So again, the dialogue itself is part of the graph. It's part of the provenance that comes along with it, and each comment you make is a nano publication that gets added. So anyway, yeah. So to actually get Whyis, it's a Python package. You can use pip install Whyis. There's a Docker image, documentation on read the docs. We have a GitHub, and it's really kind of boringly standard for these sorts of open source packages, which is a good thing, because you don't have to, you only have to bother me when you start getting stuck, or you just want to talk to me, because I'm fun to talk to. And then last bit is the credits. This is not just me. I mean, I did do a lot of it, but at RPI, this is kind of a long-term. This has been a long-term project. Sam Stouffer, Gordon Miner, Sabir Rashid, and Enrique Santos are staff and faculty, or no, staff and students. So Sabir was a student. Sam, Gordon, and Enrique were fellow staff members. We all worked on this together to kind of build this out. We also have some collaborators from other institutions, specifically from Duke, Tulumo, Fateh, and Anya Wallace helped me out a ton with the user interface, especially around data sets and data visualization. And Mike Deegan is the guy who made those hundreds of visualizations for us. And that is the last slide. So. Do we have a microphone?
About 2 minutes for questions.
Oh my God, I'm sorry.
I'll be fast with it. I just wanted to know, have you shown the Rensselaer book? Have you shown what you've done with, especially with considering the Les Miserables, the character, to the language departments at RPI?
No, because it's not, I haven't done the interesting part yet, which is to have a knowledge extractor read Les Mis for me. That's going to
I
be.
am curious because I think this will go very well if you include the text encoding initiative, TI, in your work. Talk to anybody in the English department or any of that. I think this is amazing. Thank you.
All right, thank you.
Oh, sorry. No, go ahead.
No. It's okay. So this is great work. My question is, you going back to your first slide, nano publication. Can you say in the extraction, which part is assertion, which part is provenance, and which part is public? Yeah, I just want to relate this to the example you're giving.
Okay, so when you, the assertion is the fact that Jean Valjean talked to Cosette in chapter 3, paragraph 2. Those are the facts. The provenance is that it was stored in Donald Knuth's Les Mis character thing. The publication info is the fact that, oh, I just broke the remote. Sorry, I'll fix that one before we finish. Is the fact that I, Jamie McCusker, uploaded the data set into Whyis on such and so a date.
So basically the events that how you grab that data or you make that data available, that's the publication.
Yeah, exactly.
Very, very well. Thank you. I just want to relate to your first slide.
Yeah.